Hi guys, we got a new product and it's for a product review video. It's sponsored by Owon. It's the new serial OW multimeters and let's know about it. The truth, I don't know which one of the models is it. Okay, it's the OW18E. Let's check in the system what is it about. In Owon website, I found the following multimeters. What is good about them is the Bluetooth connection, because it lets you to remotely to watch the screen and also to have data logging. This is our model. The Model E has 4 digits and a half, data logger, the multimeter itself, and thermometer. Also, it has true RMS. The Bluetooth is the kind 4, and all that applies for the Model E. And something very important, the flash light for the ones who work in industrial electronics or are related with Cat 3 and 4 and control panels for electricity. Beauty. Standard thermocouple. Okay, it's not silicone, but it feels good as the kind of a plastic it is. The tip is covered with a rubber, and a good thing about it is easy to remove it. Something I found out at this moment I like it is the flat side of the tip, because it becomes very ergonomic. Good, it has good alligators for mine lines, house at glance or industrial electronic use. Thanks guys for the battery. We got a screwdriver. That's nice. I guess it's for the battery. Thanks Owon. By the way, it's kind of heavy. Feels good. We got the specifications. Thanks guys by simplifying the size of the page and to reduce the paper consumed. That's compatible with the environment. Okay, let's get in fashion. In order to make the installation guide and all that stuff, you have to link with your smartphone the code bar and to link on the place. This is a quick guide, but the full manual is online. The first thing you are wondering is how do you feel it? Okay, it's not so light, and it has a wonderful rubber cover. It looks very stable. Okay, the battery connection system is Pokayoki. First insert this. The switch selector looks very good. Has volts, AC, DC, millivolts, ohms, diode test and continuity, capacitance, frequency in hertz and duty cycle, temperature measurement, non-contact voltage detection, microamperes, milliamperes, and up to 20 amperes. So this kind of multimeter, as it is wonderful for electronics, Cat 1, my friends, because it has microamperes and is 4 digits and a half. Also has frequency meter and capacitance meter and temperature. But in the same way, it's a wonderful device for 20 amperes and with a thick rubber cover. It makes the capability for Cat 2, 3 and 4 and to be used in industrial electronics too. And in what is helping the true RMS for the guys who repair mobile phones, to give an example, tablets and laptops. Probably not too much with the voltage, but with the current, when you have microamperes, you have more accuracy on it. And to detect battery leaks or high consume in the milliamperes, the true RMS gives you more precision for it. For the guys who work with audio amplifiers, even if you work with computers or laptops but with audio signal, the true RMS will give you more precision in the signal measurement in function of the frequency. Here we have the function generator we are going to use to apply signals and voltage to the new OW18E from Owon. I will not make a full test with calibrations because, to tell you the truth, guys, for me in this season of the year it's hard to get the right temperature in the lab. I heat my place with wood, so I have no control of the temperature variations, and I will lie to you if I go right now with calibrations. But anyway, somehow we can pick up some of the data from the datasheet and to find out if this product is what it says. The first test I will make is in voltage. It says if I am going to the scale 20 millivolts, I can see the last digit 0.001 millivolts, what means 1 microvolt digit at the end of the scale. So let's see if it is true. DC 20 millivolts DC. Here I have my 20 millivolts and I am able to see only from 10 to 20 microvolts. And the reason is because the datasheet has specifications for the scale and the maximum digit I can see. In that case, I have to reduce the voltage to 10 millivolts here, so I can get the maximum resolution from the display and to move one digit on the side. Now the scale moves away, and yes, I am able to get a measurement in microvolts there. How effective is it? Okay. The first reference I have to take care, that I am not taking care here, is the noise level from the generator and the influence of the noise on the cables. But however, if I am making a measurement of 10 millivolts, I can see the microvolts as the specification says. Now I'm going to make the measurement for the AC, and let's remember this multimeter is true RMS, so that means I can apply the voltage in function of the frequency. And let's see how efficient is it. I will apply 1 volt RMS. And I must switch from DC to AC. Alright. 1 kilohertz, 1 volt RMS. And here 1 volt. That's exactly what I'm expecting about this device. For the true RMS, it says the readings are okay between the 40 Hz and 1 kilohertz. So let's try it. (40 Hz, 1 volt, AC, RMS). Now let's go for the 1 kilohertz. And the multimeter keeps the 1 volt AC. And what happened if we increase the frequency? Let's watch it. 2 kilohertz, and now the frequency makes the voltage to drop a little. 3 kilohertz, and we get the limit of the deviation. So the multimeter is good in AC readings from 40 Hz to 1 kilohertz. That means the multimeter is according to its specifications. Resistance 1 mega ohm. Not too bad. The resistor is plus minus 1%. Supposedly less than that. What about frequency? Most of the time we make frequencies reference in multimeters. We are talking about 1 kilohertz, and that's the standard frequency we use many times for electronics components, data sheets, or audio reference, radio reference. Even when radio is high frequency, the modulation we make of one signal of 1 kilohertz. So let's try 20 hertz. Says 19.99, the maximum frequency. and we are unable to make a measurement. I will tell you why. If I want to make the measurement of 20 MHz, I must pay attention to the datasheet. Now, let's go to the 20 MHz. Let's try a little bit less. Let's try 19. Did you understand the problem, guys? This is a 2000 counts LCD screen. So if I get in the 2000 with a tolerance of plus something, I will be out of range. 19.999. And it's out of range. With 19.996, I get 19.999. So I have to make calculations of what is the deviation and to analyze if it is in the specifications of the multimeter, yes or not. Let's remember, I'm playing with the limits of the device. Congratulations anyway. Let's go now for the continuity test. Under 50 ohms is switch on. Now a quick test for the non-contact voltage detection. Let's try it with the monitor mainline wire. Alright, it works. Do you know, guys, something that sometimes fails is the oxidation in the nickel, and sometimes it's not so easy to get that touch that we want. But if I do it here in the thread of the screw, it's easier. So the multimeter is not that slow, it's the surface, the thin film we're using in the tips. Got it? At this point, it passed the test too. Current. If we apply 1 volt to 1 mega ohm, I will get 1 microampere. And I am in the microamperes scale, and yes, this is what I get here. I like it and I recommend it. It's wonderful for industrial electronics. You can make the measurement of the mine lines and protect your hands with the ruler. It's a very good shape, stable. It works fine for Cat 4 in industrial electronics and Cat 1 for electronics in the laboratory, with the microamperes, with the true RMS, with the 4 digits, even for repairing mobile phones to check the leaking in the battery or extra consuming microprocessors, microcontrollers. It's a wonderful multimeter. I recommend it. And take a look, guys, if you can buy it, if it is accessible to you in your country, you can get it. There is also in the eBay, Amazon, Alibaba, Mercado Libre, and you can find this product too. Thanks, Owon, for the multimeter. We will make more videos. See you next time.